It's exciting. Now we've started work on the Evolving a Circular Plastics Economy project, which the University of Hull's received funding for from the Engineering and Physical Sciences Research Council. So this is part of the UK government's drive broadly to contribute to solving the problems of plastics in the environment that have come to light in recent years and months, in particular through things like the Blue Planet series. At Hull, we're drawing on several lines of research that we have going on that are relevant to this, and in particular, taking a circular economy perspective is about trying to solve the problem before it starts, or prevent plastics from escaping into the environment by thinking about how they're used, what different types of plastics are appropriate for, so that we don't have the problem of them becoming waste, entering into rivers and eventually into the sea, as we've seen happening on an astonishing level. So the types of research that we're drawing on, for example, is in the chemistry department, where people are working on biodegradable plastics. That's plastics biodegradable on a relatively short timescale, not tens of years or even centuries, and drawing on bio-waste, so biogenic sources that are not taking food supplies but are from agricultural or food waste.
Welcome to the University of Hull. This is the Department of Chemistry. This is one of our research labs which is involved in the Circular Economy Plastics Grant. So in this particular lab, the project is to develop new catalysts for making biodegradable polymers. The premise is that we can change the catalyst structure by manipulating all of the groups which you find around the metal center of the catalyst, and by doing so we can actually then affect the resulting polymer properties. Okay, to give you an example, we've already made two different types of biodegradable polymer using catalysts that we've developed here at the University of Hull. So here's one polymer, sorry. So this polymer is very brittle. You can see it breaks up very easily. A different kind of polymer, again biodegradable, by changing the catalyst structure, is very tough. So you can see these types of polymers will have very different applications. So this is achieved simply by changing the structure of the initial metal catalyst. So these metal catalysts tend to be based on early transition metals. Early transition metals themselves are quite oxophilic. That means they tend to bind to oxygen. So you can imagine in the air, you have oxygen itself and you've got water, moisture. So we have to be careful when we handle these catalysts. So what we do is we use special equipment such as this inert atmosphere dry box. So this dry box here is filled with nitrogen gas. That means inside this dry box, we can manipulate the catalyst, we can weigh it out, we can characterize it with a variety of techniques. We can do all the things that your typical organic chemist would do on a bench top. So that's a nitrogen-filled dry box for handling the air-sensitive catalyst compounds. Okay, so another part of the project also involves chemical engineers at the University of Hull. They're going to take waste plastics and do all sorts of tricks with these waste plastics, such as incineration, to develop new types of materials which can then be used as feedstocks for other useful processes.
The first event we had for the project was back in January, when all the various academics involved at the University of Hull came together for a day discussing, well, not so much the project but the ideas around it, just to get used to communicating with each other, because there tends to be issues when people with very different backgrounds and training try to collaborate. You just don't necessarily use the same vocabulary. So to help with that event, we called along one of our project partners from the International Sustainable Development Research Society, so Joachim Spangenberg, who's done research of this type with stakeholders, which is known as transdisciplinary research. He's done work on that in various European and global contexts for several decades, and so came along and helped kind of break down the barriers between the University of Hull team. So today is the first stakeholder workshop for the Evolving a Circular Plastics Economy project funded by the EPSRC at the University of Hull. We're very excited to be bringing together all the organisations, companies who work with plastics in different kinds of ways, manufacturers, supermarkets, people from local authorities, people from business networking associations, some from the Chartered Institution of Waste Management. So we're representing various different perspectives on the sort of supply, use and disposal of plastics.
Hull and the Humber Estuary has had a global role for many, many years. This was the biocentre of the world in terms of processing oils, and there's some good connections. The city of Hull is very well known around the world. It's a very easy conversation to have with most people, and I think the opportunity for research, particularly on the Humber, is very, very significant. We've got all sorts of developments going on, and so the role going forward I think could be very, very significant.
Our main objective really is being able to work with businesses to make a movement from single-use items to ones which are more recyclable, but also enable those businesses to do so at what perhaps is usually perceived at a higher cost value, and looking at ways to kind of procure that to make it an easier transition for businesses. Our ultimate goal is to have a coastline which achieves plastic-free status, because not only is that us facilitating a change in attitude in the area, but it's also something that can give great recognition to this stretch of the coastline, which is known for its natural beauty as well.
I think it's the availability of recyclable solutions, biodegradable solutions. I think there's products on the market, but there's commercial challenges that go with that. And particularly when you have products established in the marketplace already, to then switch them out for a more expensive alternative, it brings with it its own challenges and getting retailer and consumer buy-in.
The project obviously that we're supporting is all around sustainability, and we've made a very public pledge, as most companies have, all around being 100% recyclable with a minimum of 25% PCR by 2025. We recognise that's something we can't do alone. We need to collaborate and link into external partners and professional organisations and really work together to try and resolve that.